And now let's solve one more question. Show that the function f of x given by f of x is equal to x into sine of 1 upon x, where x is not equal to 0, and f of x is equal to 0 when x is equal to 0 is continuous but not differentiable at x equal to 0. And now let's first check whether this function is continuous at x equal to 0 or not. Now again, from the definition of continuity, a given function is continuous at a point if and only the limit of the given function at that point is equal to the value of the given function at that point. And now in this case, to calculate the limit of the given function at x equal to 0, we shall have to calculate both its left hand limit and the right hand limit. And now let's calculate its left hand limit. And now what's the left hand limit of the given function? Now left hand limit at x equal to 0 is equal to limit x approaches 0 from the left hand side f of x, and if we write x as equal to 0 minus h, now when x approaches 0, then h will also approach to 0. So this limit can be also written as limit h approaches 0 f of 0 minus h, and which is equal to limit h approaches 0 f of minus h. And when x is not equal to 0, then f of x is equal to x into sine of 1 upon x, and which is equal to limit h approaches 0 minus h into sine of 1 upon minus h. And you know it very well that the limit of product of two function is equal to the product of their individual limit. So now this limit becomes limit h approaches 0 h into limit h approaches 0 sine of 1 upon h. And now when h approaches 0, then its limit is equal to 0. So now this limit can be also written as 0 into sine of 1 upon h. And now what's the value of sine of 1 upon h? Now the value of sine of a function is always between -1 and 1. So this limit is equal to 0 into a number which lies between -1 and 1. And 0 multiplied by any number is equal to 0. So the left hand limit is equal to 0. And what is its right hand limit? Now right hand limit is equal to limit x approaches 0 from the right hand side f of x, and which again can be also written as limit h approaches 0 f of 0 plus h, and which is equal to limit h approaches 0 f of h. And when x is not equal to 0, then f of x is equal to x into sine of 1 upon x. So the right hand limit becomes limit h approaches 0 h into sine of 1 upon h, and which is again is equal to 0 into a number which lies between -1 and 1, and which is equal to 0. So its left hand limit and right hand limit are both equal to 0. And also, as per the definition of the given function, f of x is equal to 0 when x is equal to 0. So its left hand limit, right hand limit, and the value of the function at x equal to 0 are all equal to 0. So that means the given function f of x is continuous at x equal to 0. And now let's check whether this function is also differentiable at x equal to 0. And as per the definition of differentiability, a function is said to be differentiable at a point if and only its left hand derivative is equal to the right hand derivative of the given function at that point. So let's first calculate its left hand derivative at x equal to 0, and which is equal to limit x approaches 0 from the left hand side, f of x minus f of 0 divided by x minus 0. And if we write x as equal to 0 minus h, then when x approaches 0, then h also approaches 0. So this left hand derivative can be also written as limit h approaches 0, f of 0 minus h minus f of 0 divided by 0 minus h minus 0, and which can be further simplified as limit h approaches 0, f of minus h minus 0 upon minus h. And f of minus h is equal to, now as per definition of the given function, f of x is equal to x into sine of 1 upon x when x is not equal to 0. So the left hand derivative at x equal to 0 can be also written as limit h approaches 0 minus h into sine of 1 upon minus h divided by minus h. Now cancelling out minus h from the numerator and the denominator, now this left hand derivative finally becomes minus limit h approaches 0 sine of 1 upon h. And what's the value of sine of 1 upon h when h approaches 0? Now the value of sine of a function always lies between minus 1 and 1. But when h approaches 0, it can attain any value in between minus 1 and 1. But its left hand derivative will exist if and only we get a definite value in as its left hand derivative, which is not achievable in this case. So that means its left hand derivative at x equal to 0 doesn't exist. So its left hand derivative doesn't exist. And now let's try to find out its right hand derivative. Now the right hand derivative at x equal to 0 is equal to limit x approaches 0 from the right hand side, f of x minus f of 0 divided by x minus 0. And if we put x as equal to 0 plus h, then when x approaches 0, then h also approaches 0. So now the right hand derivative becomes limit h approaches 0, f of 0 plus h minus f of 0 divided by 0 plus h minus 0, which can be further simplified as limit h approaches 0, f of h minus 0 upon h. And now putting the value of f of x as x into sine of 1 upon x, then the right hand derivative becomes limit h approaches 0, h into sine of 1 upon h divided by h, and which is equal to, now cancelling out h from the numerator and the denominator, the right hand derivative becomes limit h approaches 0 sine of 1 upon h, and which is again is not a definite number because it will always lie between minus 1 and 1, and we won't get a fixed value of right hand derivative, and that means its left hand derivative as well as the right hand derivative at the point x equal to 0 doesn't exist. So the given function f of x is not differentiable at x equal to 0. So we have proved that although the given function f of x is continuous at x equal to 0, but it is not differentiable at x equal to 0.